As the James Webb Telescope approaches full functionality in just about 2 weeks' time, NASA plans to look into some of the most interesting planets that we've managed to find and study. The Webb will give us a whole new insight into these planets and might even give us new information that we previously had no clue about. These super-Earths, as they're called, range from bizarre to downright weird. Let's look at the 2 super-Earths that the James Webb Telescope will research. Before we get into the specifics, we might want to first know what super-Earths actually are. And no, super-Earths aren't just Earth-sized planets with capes, if you were wondering. A super-Earth is an extrasolar planet with a mass higher than Earth's but substantially below those of the solar system's ice giants like Uranus and Neptune, which are actually 4.5 and 17 times that of Earth's. The term super-Earth only concerns the mass of the planet and so doesn't actually have anything to do with the surface conditions or habitability. Super-Earths are also called gas dwarfs, which may be a little more accurate for those at the higher end of the mass scale, although mini-Neptunes is a more common term. The telescope's scientific syndicate has plans to explore strange new rocky worlds in incredible detail from 50 light-years away. The work will serve as quite the challenge for the new observatory, which is scheduled to be commissioned in just a couple of weeks. Why are there going to be a challenge, though? Well, rocky planets are more difficult to sight than gas giants with the current telescope technology we have, because of the smaller planet's relative brightness next to a star and their relatively tiny size. This is where the Webb comes in. Webb's powerful mirror and deep space location should allow it to examine 2 planets slightly larger than Earth, which we've come to know as super-Earths. If you were thinking that they'd be Earth-like on the surface, then you're going to be wrong. We aren't going to be vacationing there anytime soon. Neither of these worlds is habitable as we know it, but investigating them could still be a proving ground for future in-depth studies of planets like our own. The 2 planets Webb officials highlighted include the super-hot, lava-covered 55 Cancri e and LHS 3844b, which lack a substantial atmosphere. We've spoken about 55 Cancri e in a previous video, and scientists are gearing up to study this one again because, let's be honest here, this planet is absolutely fascinating. 55 Cancri e orbits less than 1.5 million miles from its Sun-like star. To put that into perspective, that's 1/25th of the distance between Mercury and the Sun. The planet completes one circuit in less than 18 hours. That's right, 1 year on that planet is literally 18 hours. That means if you were 25 years old on planet Earth, on 55 Cancri e, you'd be 12,175 years old. Scientists also assumed the planet is tidally locked to the star, meaning one side always faces the scorching sun, although observations from NASA's Spitzer Space Telescope suggest the hottest zone might be slightly offset. The planet's surface temperatures are far above the melting point of typical rock-forming minerals, and the day side of the planet is thought to be covered in oceans of lava. Charming, isn't it? Planets that orbit this close to their star are assumed to be tidally locked, which means that the hottest spot on the planet should be the one that faces the star most directly, and the amount of heat coming from the day side shouldn't change much over time. Here's where it gets a little weird. This doesn't seem to be the case. Observations of 55 Cancri e from NASA's Spitzer Space Telescope suggest that the hottest region is not the part that faces the star most directly, while the total amount of heat detected from the day side does vary. Scientists say the offset heat might be due to a thick atmosphere that can move heat around the planet, or because it rains lava at night in a process that removes heat from the atmosphere. Oh yeah, I forgot to mention, scientists think it rains lava on this planet. That's right, rains lava. and you thought things were going to get better. So, does 55 Cancri e actually have a thick atmosphere? Scientists claim that one explanation for these observations to occur might mean that the planet has a dynamic atmosphere that moves heat around. 55 Cancri e could have a thick atmosphere dominated by oxygen or nitrogen, explained Renyu Hugh of NASA's Jet Propulsion Laboratory in Southern California, who leads a team that will use Webb's near-infrared camera, or NIRCam, and mid-infrared instrument, or MIRI, to capture the thermal emission spectrum of the day side of the planet. If it has an atmosphere, Webb has the sensitivity and wavelength range to detect it and determine what it is made of, Hugh added. 2 teams will test these hypotheses, one led by research scientist Renyu Hugh, who will examine the planet's thermal emission for signs of an atmosphere, while a second team led by Alexander Brandecker, an associate professor from Stockholm University, will measure heat emittance from the lit side of 55 Cancri e. Also, is it actually raining lava in the evening on 55 Cancri e? Well, another fascinating possibility is that 55 Cancri e is actually not tidally locked. Instead, it may be like Mercury rotating 3 times for every 2 orbits, which is known as a 3-to-2 resonance. Orbital resonance is a resonance of 2 orbiting bodies exerting a regular, periodic gravitational effect on each other. Their orbital periods are calculated in rations. So, when we talk about Mercury's orbital resonance being 3-to-2, it means that for each orbit around the Sun, Mercury completes exactly 1.5 rotations, thus requiring 2 complete orbits to return its same side to the Sun at its starting point. Alright, back to 55 Cancri e. Now, as a result of the hypothesized 3-to-2 resonance that scientists think this planet might have, the planet would have a day-night cycle. Alexis Brandecker, a researcher from Stockholm University who leads another team studying the planet, explained, "That could explain why the hottest part of the planet is shifted. Just like on Earth, it would take time for the surface to heat up. The hottest time of the day would be in the afternoon, not right at noon." Brandecker's team plans to test this hypothesis using NIRCam to measure the heat emitted from the light side of 55 Cancri e during 4 different orbits. If the planet has a 3-2 resonance, they will observe each hemisphere twice and should be able to detect any difference between the hemispheres. In this scenario, the surface would heat up, melt, and even vaporize during the day, forming a very thin atmosphere that Webb could detect. In the evening, the vapor would cool and condense to form droplets of lava that would rain back to the surface, turning solid again as night falls. So, 55 Cancri e will provide us with insight into the exotic geology of a world covered in lava. But LHS 3844b might give us a unique opportunity to analyze the solid rock on an exoplanet's surface. Just like 55 Cancri e, LHS 3844b orbits extremely close to its parent star, completing 1 revolution in 11 hours. That's 7 hours less than 55 Cancri e. When you think about it, if you're 25 years old on Earth, on LHS 3844b, you'd be 19,922 years old. That's a little too many birthdays. However, because its star is relatively small and cool, the planet is not hot enough for the surface to be molten. Spitzer's observations also indicate that the planet is highly unlikely to have a substantial atmosphere. A team led by astronomer Laura Kriedberg at the Max Planck Institute for Astronomy hopes to catch a signal of the surface using spectroscopy, in which different wavelengths of light suggest different elements. Thermal emission spectrums of the planet's daylight side will be compared to known rocks like basalt and granite to see if they can deduce a surface composition. Kriedberg said in a statement, "The 2 investigations will give us fantastic new perspectives on Earth-like planets in general, helping us learn what the early Earth might have been like when it was hot like these planets are today." So, what is the surface of LHS 3844b really made of? Well, it's evident that we won't be able to image the surface of LHS 3844b directly with Webb. But the lack of an obscuring atmosphere makes it possible to study the surface with spectroscopy, as previously mentioned. Kriedberg explains, "It turns out that different types of rock have different spectra. You can see with your eyes that granite is lighter in color than basalt. There are similar differences in the infrared light that rocks give off." Kriedberg's team will use MIRI to capture the thermal emission spectrum of the day side of LHS 3844b, and then compare it to spectra of known rocks like basalt and granite to understand its composition. If the planet is volcanically active, so the spectrum could also reveal the presence of trace amounts of volcanic gases. The importance of these observations goes far beyond just 2 of the more than 5,000 confirmed exoplanets in the galaxy. Kriedberg says, "They will give us fantastic new perspectives on Earth-like planets in general, helping us learn what the early Earth might have looked like when it was hot like these planets are today." These observations of 55 Cancri E and LHS 3844b will be conducted as part of Webb's Cycle 1 General Observers Program. General Observers Programs were competitively selected using a dual anonymous review system, the same system used to allocate time on Hubble. Webb is now working through later-stage commissioning procedures like tracking targets in the solar system and moving between hotter and colder attitudes to testing the strength of its mirrors and instrument alignment. The $10 billion observatories should be finishing their commissioning in a matter of weeks or so and move into Cycle 1 of observations then after. So, what do you think Webb will find on 55 Cancri E and LHS 3844's surface? And what secrets do you think lurk in the shadows of these super-Earths? Let us know in the comments, and as always, thanks for watching Space Rumor.